Hey everyone, I'm Anish and welcome back to PrepFusion. So we had to stop the previous lecture basically due to we are passing our threshold and we had few more questions to solve, right? So in this lecture, this is the lecture 6B of Nyquist plot. So this is the last lecture of Nyquist plot. So here we'll solve few more questions and I will give you about different things, right? How to use both Routh, Hurwitz and the Nyquist plot together, right? In a question. So yeah, let's start with the first question basically. So what is the next question telling us? The Nyquist plot of the OLTF is given, and the Nyquist plot is okay. Nyquist plot is not given. It has told that it does not encircle the critical point minus 1 comma 0. The Nyquist plot of this OLTF does not encircle the critical point minus 1 comma 0. Okay. Of the obviously g of h of s plane, it has not mentioned here, but we will assume yeah, it is talking about the gs h of s plane when k is equals to 10. So when k is equals to 10, it has told that it does not encircle the minus 1 comma 0 point, but does encircle the critical point minus 1 comma 0 once when k is 100. So when k becomes 100, it encircles that critical point. When k is 10, it does not encircle the critical point. Then the closed loop system, it is talking about the stability, right, for different values of k. So what you can do, there are two methods to this. So now we obviously will use that Routh method also and this method also. So method one is simple Nyquist plot, right? Nyquist plot. So basically what first thing what we know, we have been given the OLTF, and from the OLTF can you get any information? If you have been given the OLTF, always find the number of poles on the right hand side of the OLTF. Okay, OLTF. So are there any poles on the right hand side? This is on the left hand side pole. And what is this? This is like just use that Sridhar Acharya formula, or simply directly from the Routh criteria. You can see that all coefficients are positive, so there are no poles on the right hand side. So this has 0, this also 0. Okay, hence I can directly say p plus OL equals to 0, or what you can say is, like, what you can do is find the roots of the second order equation. Okay, and you will find out that this is coming to be on the negative side of the exponent, right? Roots are on the negative side of the exponent, so roots are on the negative side of the exponent. So from OLTF, my p plus OL equals to 0, which is simply equals to same as p plus 1 plus OL. But now this has got installed into your brain, I hope. So this is, which is same as this, right? Same as this. So now this is this, right? Now what I will recommend is, we have to find the number of encirclements around the minus 1 comma 0 point. So for k equals to 10, it has told it is 0. So now we'll decode the other information. For k equals to 10, my n minus 1 comma 0 is 0, right? Okay, and like I will do this now. I will find the stability for this one. So what is my formula again? That formula, this is 1 n minus 1 comma 0 equals to p plus 1 plus OL minus z plus 1 plus OL, and p plus, this is 0, right? This is 0 and this is also 0. Hence my z plus 1 plus OL equals to 0. Hence I don't have any closed loop poles on the right hand side of my S plane. So this system is stable. System is stable. Closed loop poles are on the, so system is stable basically. Left hand side, so system is stable. Okay, system is stable. Now what about when k is 100? So when k is 100, it is telling us that it is encircling the critical point. Okay, the direction it hasn't told us, so that is an issue. So if they should have told us the direction, right? If they haven't told us the direction, if we are getting the value of z as negative, we'll assume other direction. So what I will assume is this is encircling in the anti-clockwise direction, right? Anti-clockwise, the positive direction basically. Okay, if I get a negative value, right, of z, then I will change my direction. Okay, so sometimes it may happen they don't give the direction, then you have to assume the direction, right? Although in this question they should have given the direction. Assume clockwise direction of Nyquist contour and anti-clockwise direction of the encirclement basically of the encirclement, right, in the anti-clockwise direction of the encirclement. So yeah, that is what we assume. Now here it is given 1, right? It is encircling, but does encircle the critical point once. Okay, 1 k is equals to 100. So k is 100. I assume it is anti-clockwise, so it is 1. So my p, that is same, right? P plus this is same, this doesn't change, right? So just hold on a second. Yeah, sorry for the interruption again, like one call came up. So my n is minus 1 comma 0, right? N is minus 1 comma 0 equals to 1. Okay, in the anti-clockwise direction I'm assuming. Okay, now if I put this in the equation, n equals to this 0 minus z, so my z plus is coming negative, which is not possible, right? Negative, not possible. Negative, not possible. Okay, like z plus is coming out to be minus 1, right? To minus 1. Okay, so what we'll do, we'll assume different direction of contour. So this contour is not correct. Assumption of contour was not correct, or whatever you might say. Like assumption of contour may be correct, but if the question has told us that it is encircling in the clockwise direction, then also it is correct. But I have to assume some convention. So what I will do is, I should have written it down in the question. While making the question I made a mistake. I should have written it down that once in the anti-clockwise direction. I should have written it down. So at least one thing should be given, right? Anti-clockwise direction, or the Nyquist plot should be given. So that's my bad. Okay, maybe I written it down, then again I deleted it. Okay, so yeah, the question is anti-clockwise direction, then this question will be correct. So now this is getting wrong, so what I will write is my assumption for Nyquist was wrong. Okay, then what is my assumption? Then what I will say is that this is anti-clockwise. Okay, this is anti-clockwise. Now this is anti-clockwise, then my n minus 1 comma 0 is minus 1, because I'm expecting a clockwise encirclement, right? Opposite direction of encirclement. So n is minus 1, and this is anti-clockwise, right? Anti-clockwise encirclement. They have given us in the question anti-clockwise encirclement. So if n is minus 1, now what you do? So basically you do, right? So now you put in the formula, minus 1 equals to 0 minus z plus 1 plus ol. Okay, so my z plus will be 1. So I will have one right hand pole of one right hand closed loop pole, right? One right hand side closed loophole, basically one right hand side closed loophole, right? So I will have one right hand side closed loophole. So what is the question telling? Yeah, it is unstable basically. So when k is 100, it is unstable. So you could have done it very fast. Okay, I'm just explaining everything to you, that's why I'm doing it very slow. Just it will take 1 minute, right? So for k equals to 100, this is unstable, and for k equals to 10, this is stable. So option B is correct. Okay, Oh, all of them are option A. Okay, I have to change this. B. No, this is not C. Really? Okay. So this is about the this method. Now, can we solve this using any other method? Yes, we can, right? How we can solve this any other method? Basically, you can use the Routh-Hurwitz criterion. So here I will tell you how to use the other method also. If you are confused in Nyquist, or sometimes it's easier to solve in Routh-Hurwitz instead of Nyquist, right? So then we'll solve it using Routh-Hurwitz, because Nyquist problems can be solved using Routh-Hurwitz also. Okay, because they both of them tell us the absolute stability. Sometimes it is easier for us to solve with Nyquist. Sometimes it is easier for us to solve with Routh-Hurwitz. You have to choose which one. That only you will get understand. That only you will understand when you solve multiple questions, right? Multiple questions. That only you will understand when to use what method, right? So method 2, Routh-Hurwitz criteria. Okay, so Routh-Hurwitz criteria. So what you do, we have been like, whenever OLTF is given, you can use two methods. Whenever OLTF is given, you can use two methods, right? As I told in my that previous bisection also, that how to solve Nyquist problem. So here I'm basically doing the application of that. So we'll copy the OLTF, okay, and we have to talk about the closed loop stability. So what I will find the closed loop characteristic equation, and from there I will find the about the root side, whether the roots are lying on the right hand side or the left hand side. So this is my g of h of s, right? Now what is my 1 plus g of h of s? Simply 1 plus g of h of s equals to k divided by s square plus 2s into s plus 1. Okay, this is 1 plus g of s, so this should be equals to 0. So like my equation becomes, this is s cube plus 2s square plus 3s plus s square plus 2s plus 3 plus k. Okay, so now let me like rewrite everything, right? Sort everything out. This is s cube, and this is simply plus 3s square, right? 3s square plus 5s plus 3 plus k. Okay, did I have any k with? No, I don't. So basically this is s cube plus 3s square plus 5s plus 3 plus k equals to 0. Okay, this is what my characteristic equation is, and from here this is basically telling me about the poles of the closed loop poles, basically closed loop system, right? So now we can use a shortcut. What is shortcut? That internal product should be greater than external product for what? For system stability. So what do? You basically make internal product. What is internal product? 3 times 5, right? Should be greater than external product, that is 1 times 3 plus k. 1 times 3 plus k. Okay, so my k from this inequality should be less than 12 for stability. Okay, now you just check the options, right? You check the options, like where my k is less than 12 and it is stable, and if my k is greater than 12 it is unstable, if my k is equals to 12 it is marginally stable. So good derivation of Routh, right? So like here I can see obviously k is less than 12, so this is stable. If k is greater than 12, this is unstepped. Only this option will suffice. Other options will not be eligible for this, right? Will not be incorrect. They will be. So this was the question 21st. Now let's go to the next question. So next question is telling us that we have a unity feedback control system characterized by the following open loop transfer function. The OLTP is given, so whenever OLTP is given, you can do it obviously with route, but you have to understand that whether doing it with a route will help you in solving it faster, or it may take more time. That only will come with experience when you solve each question, right? When you solve each question. So Nyquist contour is given, OLTP is given. Okay, this contour, this plot, Nyquist plot is also given. Now it is telling us that my k is 0 to 1. So k, right? K is the system parameter. K is varying 0 to 1. And k is also here given, right? K is also given here. Okay. So this question has made us easier that it has given k over here. Okay. If k wasn't given, something else was given, 10k or something, then this question would have been again become trickier. Okay. But as simple k is given, then which is very simple. K is varying from 0 to 1. Now if k is varying from 0 to 1, what does this mean? At k equals to 1, what does this point become? This point becomes the critical point. And if it varies from 0 to 1, what does that mean? So if let's say this is my -1 point. If this is my -1 point, k is varying from 0 to 1, so it never touches my -1 point, so it never touches my critical point. So there aren't any encirclement around the critical point. Okay, that is one point to note here. Also here what I can observe is the OLTF stable or not. Is the OLTF stable or not? Like whenever you're trying to solve the Nyquist, right, always check if the OLTF is stable or not. OLTF is stable. If you said yes, then you skipped a bit. Why? Because you might have just assumed that this is a second order equation. This is s square plus 3s square, 3s plus 10. But this isn't second order, right? This is what? Third order, and there is coefficient of s missing. So whenever there is a coefficient missing, obviously the system will be not stable. Like the open loop transformation won't be stable. Okay, that we know. Open OLTF won't be stable. So obviously we have some poles lying on the right hand side, right? So this you can solve using three methods. Only with the Nyquist, both with the Nyquist and route, and only with the route. So we'll see all the three methods. So first method is with the Nyquist itself, right? Method 1. The Nyquist plot only. So if you want to solve it with the Nyquist plot only, how we'll solve it? So this is the Nyquist plot. Okay, I've just drawn it same ditto. Okay, as it is given over there. Now, what are the informations given to us? One of the information is given to us is that, like, what we can find is we don't know about like how many poles are there on the right hand side of the S-plane, right, of the OLTF. If we don't know about that, then we won't be able to comment about the right hand side poles of the closed loop transfer function. Okay, we have to know about the right hand side poles of the open loop transfer function. From there, what we'll do, we'll find the we'll put that in the -1,0 encirclement equation, and from there we'll get our solution, right? But hence we have to find P plus OL, right? P plus OL. How to find that basically? So what you can do is basically how to find that, we use the first equation, right? What was the first equation? It was the n 0,0 encirclement around the origin, which is equals to P plus OL minus Z plus OL basically. Okay, so it is P plus OL minus Z plus OL. So now how many encirclements do I have? I have around the origin, I have one encirclement, right, and two encirclements. Okay, like you can use that method also, where we put a straight line. Okay, but sometimes where you will get stuck is like questions like this, right? Here you will get stuck. Okay, here you will get stuck if you want to use that method. So let's say this is my critical point, and if you want to use a straight line, so you will get confused. So if you get confused, don't use this method. Just use the simple encirclement method that I was talking, right? Just swiping the red pen and just checking how many encirclements are there. Don't use this method. For the people who want to use this method, how to use this method to find the number of encirclements? What you do, you from the critical point, you draw a straight line and cut the contour. Okay, now if you cut the contour here, what do you see? You see one in the anti-clockwise and one in the clockwise. So it cancels out, it becomes 0. Now you might say, sir, you can also take this straight line here. straight line here. So if I take this straight line here, what happens? Okay, let me just, yeah, take this line here. What happens? One is in the anti-clockwise, one is in the clockwise. Okay, and also there is another cut. There are two cuts here. So if there are two cuts here, they cancel each other out of the same plot, right? So what is this cut telling us? This is in the clockwise telling us, this is in the anti-clockwise telling us. Okay, that's why they both of them cancel each other out, and we are only left with these two. Okay, that's why. So if this is confusing to you, don't use this method. Don't use this. Only use the simple method. What is the simple method? This, let's say this is the critical point. One is the like encirclement around that critical point in the anti-clockwise direction, and there is another encirclement in the clockwise direction. Sorry, not in the anti-clockwise, in the clockwise direction. Okay, there aren't any encirclements around the critical point of other two contours, right? Okay, use this method if you get confused by the previous method, right? So yeah, this was basically the brief summary, because I told you that method, right, in the previous. That's why, like, I thought, yeah, it may become a bit difficult for you to solve using that method only. So I told you the two methods here, right? So now let's come back to our question. So here, what is my n0, 0? N0, 0, I can see one in the anti-clockwise direction and another one in the anti-clockwise direction. So two in the anti-clockwise direction. So I have two in the anti-clockwise direction. And what is P plus OL? What is P plus OL? P plus OL, right, is what I have to find basically. P plus OL is what I have to find basically. And what is Z plus OL? What is Z plus OL? So Z plus OL is number of zeros on the right hand side. How many number of zeros are on the right hand side of the OLTF? None, right? None. It is only s equals to minus 2 is one of the 0, and it is on the left hand side. So ZOL plus is 0. So we have been given the information about ZOL plus, and from there we have to find the POL plus, and from there we'll find the Z1 plus OL plus. So it is like circling around, right? So this is so this is not minus 2, sorry, this is 0, because we have zeros around on the right hand side of the experiment. So this is 0. So my POL plus, I have two poles on the right hand side of this pen. Obviously you can solve it using the route, right, and get your sign sheets, and that will do in the next method basically. So yeah, that is what this is. Now you put this equation in the second equation, right? Like you put the value of P plus OL in the second equation. So this is equals to simply P plus 1 plus OL. So now I will use the second method basically. N minus 1 0 equals to this P plus 1 plus OL minus Z plus 1 plus OL. Okay, so if I use this one, right, now what is my encirclement around this minus 1 point? So what I told, right, if I'll just copy this contour. I'll just copy this contour, right? And if I, let's say I draw a asymptote of which real part is minus 1 0, right? Minus 1 0. Minus 1 0, right? Whose asymptote is minus 1 0. If its asymptote is minus 1 0, then what does that mean basically? So my k is varying from 0 to 1, so it will never touch the asymptote. So I can, like, how many encirclements I will always have around the minus 1 0. I will always have, like, this will never reach this point. So I can exactly find the encirclements here. This will never reach this point. Okay, as this will never reach this point, my all these plots will never reach this point. So how many encirclements will I have around this minus 1 0 point? These plots will never reach this point. So how many encirclements? 0, because I have nothing here. I have nothing here, right? No plots are reaching this point. This is my minus 1 0 points, as k is varying from 0 to 1, right? K is varying from 0 to 1. It will never reach this point, hence I will not have any plots here. Okay, and I will not have any encirclements. All are lying around here in this region. Okay, I have nothing here, so it is 0. So n minus 1 0 is 0. Okay, now what is P plus 1 plus OL? That already I found out, and this is minus Z plus. Okay, so yeah, this is one more thing, and obviously, right, this is in the anti-clockwise direction. That's why I wrote it plus 2. Why? Because my contour was in the clockwise direction, hence my encirclement is in the anti-clockwise direction, and I took it as positive. Okay, that is one thing. This is Z plus, and Z plus equals to 2. Z plus equals to 2, right? So Z plus is equals to 2 itself. So it is not simple, z is 1 plus OL. So I have two closed loop poles on the right hand side of my S plane. Okay, so by this you can directly tick mark that my answer will be 2, right? This is talking about the number of poles of the closed loop transfer function that lie in the right half of the S plane basically. So this is 2, this is 2. So now let's go for the method 2, which is a mixture of both Nyquist and Routh. Okay, so if someone doesn't know about the concept of that encyclopedia on the origin, what they will do is they will find the number of poles, okay, on the right hand side of the S plane of the g of hf g of hfs transfer function of the OLTF with the help of Routh. Okay, so method 2, both Nyquist and Routh. Okay, both Nyquist and Routh. So like we have to find the POL plus, okay, P plus OL. So we'll find POL plus with Routh orbits, right? How to do that? I will write g of h of s. What is my g of h of s, right? G of s h of s equals to 10k s plus 2 s cube plus 3s square plus 10, right? Plus 10. So this is this one. Now what we do? We write the route table for this to find the poles, right? Or to find write this in route table, right? Standard route table. So obviously we have a coefficient missing basically. So this is 3s square uh, plus 0 times s plus 10 equals to 0. So we'll write this in route table. Okay, here I have s cube, here I have s square, here I have s to the power 1, here I have s to the power 0. Okay, so what is this? S cube is basically 1, s to the, this is 0, this is 3, and this is 10. So what you will do is this will be minus 10 by 3. Okay, and this is 0 itself. Okay, so I'm doing this directly, not explaining anything. Okay, and what is this? Am I doing this correctly? This was s square, right? Yeah, s cube s square, yeah. And this will be simply, this will come directly over here, right? You remember, right? We studied it out. So this will directly come over here. This is 10 and this is 0 itself. So how many sign changes I have? I have plus plus minus plus. So I have what? Here one sign change and here one sign change, right? Sign change. Okay, so I have two sign changes, basically two sign changes. So if I have two sign changes, what does that mean? That means basically that I have two right hand poles, right? Hence two right hand poles, basically I have two right hand poles, right? So if I have two right hand poles, what does that mean? Now I will simply put that in the same equation, right? Put in the same equation. Okay, and I will find the solution. This is this. Now I'll find the solution, right? simply copy paste, right? So like this method is copied itself, right? So yeah, after this obviously I will use this like same method only. Obviously that's why I told it that we'll use both Nyquist and route. Now if you only want to use route, okay, you don't use this because like if someone wants to use this, they can use this. Now if you only wants to use someone only wants to use route, right? So if someone only wants to use route, method 3, route Hurwitz criteria. Okay, if someone only wants to use route, what they can do is like this is one, like I will write the characteristic equation. So 1 plus g of h of s, which is k into s plus 2 basically. Okay, and we have what, s cube plus 3 square plus 10 equals to 0. So basically this becomes s cube plus 3s square plus 10 plus k into s plus 2 equals to 0. ks plus 10, not this, 10 plus 2k basically. So like we can obviously find the condition value of k for which the system will remain stable or unstable. That simply we can find it with internal product and external product. So for stability, my internal product should be greater than external product, right? So if my internal product is greater than the external product, what does that mean? So that means greater than this 10 plus 2k, right? So if this is greater than this 10 plus 2k, then hence k is greater than 10. So for k greater than 10, system will be stable, but the range given is between 0 to 1. Okay, the range given is between 0 to 1. K is never going to 10, never going greater than 10, so it will always be unstable. So definitely there will be some poles on the right hand side of my S plane, so these options will be there, this option is eliminated. So how many, that we have to find with the route array table, right? So always unstable. Okay, always unstable. So now basically now you just write this in the route table. So let me make the route table. S square s to the power 1 s to the power 0, right? S to the power 0. Okay, now what you write, this coefficient 1k, okay, 1k, and this one is 3 10 plus 2k, 3 10 plus 2k, 3 10 plus 2k, right? So now you write this. So now basically solving, this becomes k minus 10 plus 2k divided by 3 itself, and here it is 0, so this will directly come down here, right? This will directly come down here. This is 10 plus 2k. Now if my k is varying, okay, I will simplify this further. This is minus 10 by 3, and this is like k minus k by 2k by 3, k minus 2k by 3. So this is plus k by 3. Okay, simply plus k by 3. Okay, as my k is varying between 0 to 1, right? K is varying between 0 to 1, hence this will always be always negative. always negative, right? This will always be negative. So if this is always negative, what does that mean basically? If this is always negative, this means that I have a sign change. This is positive, this is positive, this is negative, and again, right, this is varying from 0 to 1, so this is 10 plus something positive, so this is positive again. Hence I have again, right, no sign change. Here I have one sign change, here I have one sign change. So one sign change and one sign change. So I have two sign changes, hence total so two sign changes, right? Two sign changes, hence two closed loop poles on the right hand side of S plane, right? So two closed loop on the right hand side of this plane. So answer will be 2. So from here we can check, right? Answer will be 2. Okay, simple. So this was basically it for this question. Now let's solve the next question basically. So what is the next question telling us? So next question, we have been given the Nyquist plot of a stable transfer function. So whenever they give you, right, stable transfer function, that means of g of s, they are telling stable transfer function g of s. That means what? My poles of the g of s are on the right hand side are 0. Okay, so I'll write this information down as I'm reading. I try to decode things, right? So from the question itself, I can say that P plus OL equals 0. It has told us that it is stable OLTF. This is fine. Now we are interested in the stability of closed loop system. That is okay. Now we've been given this, what, Nyquist plot, right? Nyquist plot is given, okay, and this has given that this is a unity feedback system. That is also fine. Now it is asking us which of the following statements are true, right, or is true. This was a GATE 2009 question. Then MSQ wasn't there, so is true. Only one option will be correct. And also it is asking about the gain and phase margin. So this will also revise you the concept of gain and phase margin also. So how to solve this? So what you will do this is first you have to understand about, like, read the options. You can eliminate the options, and from there also you can understand which options are true or not true. This is telling us g of s is an all pass filter. So if g of s is an all pass filter, so you will study this in analog circuits, that for an all pass filter the magnitude response is constant and the phase response is, like, it rotates a whole circle. It is correct that, yeah, phase is rotating a whole circle, that is correct, but the magnitude should remain constant. Is the magnitude here constant? You might say, yes sir, this is circle magnitude is constant, radius is constant, but radius from where? From its center. But from where do I measure the magnitude? I measure the distance from the origin, right? That's how I measure the magnitude of any any function, right? If I'm plotting it in the real and imaginary axis. From the origin, the magnitude is happening, what? Here the magnitude is increasing, and then again, like, here it is maximum, then it is starting to decrease here, right? Starting to decrease. Here it is minimum, and then again it is increasing. Okay, so magnitude is changing. Okay, you will study this in all analog circuits. Here, there you will study different types of filter, right? So also for all pass filters, my pole zeros are in the symmetrical location. Pole zero in the symmetrical location. That's why my magnitude is same, constant, and other things, phase changes, right? So eliminating options. So in this case, right, you have to read obviously all the options, then only you can understand. Or if you directly solve the question, right, MSQ comes, then you have to obviously read all the options. But if you directly solve the question using Nyquist, only one option will be correct, and you will find out that yes, this was very easy, only that option is correct. But if you don't want to use that option, right, then you have to use this, right? So you have to obviously, if MSQ has came up, then obviously you have to read all the options. So for option A, we know magnitude response. Here, right, do keep that in mind. The g of it is talking about the g of s. It is commenting about the g of s and not about the closed system. This is only talking about the open loop system. So we will comment about the open loop system, right? So magnitude response is constant. Okay, for all pass filter. But not constant, but here it is not constant basically. So this is one thing. So hence option A is eliminated. Option A is eliminated. So this is gone. Okay, what about option B? Option B will come, right? Basically g of s has 0 in the right half plane. So we have to check this one, if g of s has 0 on the right half plane. So for that we can use Nyquist, right? We can use Nyquist because we don't have the g of s. Okay, we don't have the g of s given in terms of s, right? So we can't use Raut. We'll simply use the Nyquist. So it's talking about g of s has 0 on in the right half plane. Now if it is talking like that, then obviously it is talking about the 0 of g of s, not of 1 plus g of s. So simply you will see the increment around the origin. Okay, not around the minus 1 comma 0 point. So they have given the both points. Just be careful, you will see the increment around the origin, right? And Nyquist contour is not given. Okay, we'll assume it is clockwise. If some error arises, right, then we'll assume the opposite direction. So for B, what we'll do, simply we have to find the like stable OLT is given. So P plus OL is 0. Okay, now if P plus OL is 0, right, P plus OL is 0, we need to comment about the open loop zeros. So we'll comment about the increment on the origin minus Z plus OL. Now we're assuming clockwise direction of Nyquist contour. Okay, Nyquist contour. Okay, if we're assuming this, right, if we're assuming this, then what does this mean? This means that we have one increment around the origin in the clockwise direction. So n equals to 1 in the clockwise direction, but obviously this should be in the anti-clockwise direction, opposite of the Nyquist contour. So it is minus 1, right, minus 1 in the clockwise direction, because I'm expecting anti-clockwise as positive direction, right? So this will be minus 1 equals 0 minus Z plus OL. So Z plus is coming positive, so hence there is no error in our assumption. So equals to 1. So we have 1 right hand 0. Right hand 0. So obviously from here we can say, right, option B is correct, and we can move on to other question. But let's just stay in this question and check the other options as well, right? Can we eliminate the other options as well? So like if you are in a state of confusion or something, right, whenever you are in a state of confusion, so what you do is basically you try to like you don't know if this option is sure or not, you try to eliminate the other options. Okay, so here is telling us g of s is the impedance of a passive network. So what do you mean by passive network? Passive network should have its poles and zeros on the left hand side of my s plane. Okay, in active network, poles and zero can lie on the right hand side of my s plane, but this can't be possible. Okay, passive network will always have its poles and zero lie on the left hand side of my s plane. Okay, right hand zero is not possible. So You will study this in analog circuits, right? Active networks, passive networks. Like you have studied network theory about passive and active networks, but with poles and zeros you haven't studied. That you will study in the analog circuit course. Okay, so this is about the passive network. And now as we have 1 0 on the right hand side, hence this option is not correct, as we have 1 0 on the right hand side. So this option is not correct. And what about the D? What is D telling us? D is telling that g of s is marginally stable. Obviously g of s is marginally stable. G of s is stable. The question has given stable transformation. How can g of s be marginally stable? Okay, so g of s is stable. In the question itself it is given, right? Given. Okay, so that's how you eliminate the other options. So yeah, that is it basically for this lecture, and that is it for this Nyquist plot. So I hope you enjoyed all the lectures, right? I hope you enjoyed all the lectures. And next up we will like start the Bode plots, and like give me the feedback and how you like the Nyquist plot, how you like the explanation and stuff, right? And any doubts you have, anything you have, you can ask in the comments, or you can ask in the Telegram group. And also do please hit the like button if you like my explanation and stuff, right? So yeah, please hit the like button, and I will see you in the next video in the with a new chapter, that is a Bode plots basically.